right, food. Food helped a lot. Um, so, like I said again, what I'm doing is just kind of live streaming my work. What I'll do is I'll condense this down and review my code, yada yada yada, on actual smaller, more manageable videos for other people. But leave these live streams up in case anyone's interested in looking at how I think the thought process moving into what's being created, etc. Actually, let me pull. Let me pull this up on my phone. Come on. There we go. Bam. There we go. All right. Sweet. So, in the last live stream, basically I created the first flat table that we're going to use, and I'll switch the scene over now. So if we have this destination table, what we can do is create a procedure that looks for the specific tree, or more importantly, let's think of it as how do we get the data from where are my refs? There you go. From a text realm class family type into this table, along with the transaction class family type into this particular table. We could create a trigger and code it specifically to move that data, or B, do it how we're supposed to with reuse, because we don't want the same code floating around multiple times. So the idea for this is if we have, let me just copy a smaller table because it's going to be easier. Let's call it table 23. Doesn't matter what it is. So if we have a specific table, we know that in our system, we have a data set and data point table. So not only do we know that this table is defined and the data point table is the column, or are the columns of the data set or a table, and those data points have types, so we know they're integers or not. We have all of this information inside of our table, or our structure. So instead of trying to create different flavors of the same code for each trigger, what we can do is, basically use the numbers as some sort of relationship. So if I have table 23, and let's say I have flat table 01, because we want to think about this in a more abstract mindset. And this is going to 1, 2, 3, 1, 2, 3. Yep, okay. There we go. Oh, I did this all backwards. Again. These will be our ones. So if we think of these, columns as numbers and these just all columns as numbers, what we can essentially create is a program or a module, source and destination. Let's give it a source and destination of the table 23, and all IDs. We don't want to do this with actual text, because if we change the text or change the location, we're going back to this is where the single area of information is stored. The data set name is stored in the data set table. There's no reason to have the data set name here, but just for this particular example, this is what I can do. Abbreviation and type. So we have this source data moving towards a destination. So it's really not enough that we just know the table and column, because if my destination is name 1, abbreviation 1, and type 1. Oh, I messed that up. This record is basically just going to keep overwriting in the same area. You know, it'll say person 1, and then as it goes down their updates, it'll say person 2. So we'll never get this expansion. So it's not just that we need the source table and the source name, but we need the source, essentially PK. So we're going to take this column, borders. So this will be source. And it's almost like a pivot without requiring a pivot, where if we can look at this as a multidimensional cube type item, we're going to say, this first record for this particular ID, our destination will be in this area. So by adding on to that, how it would look is based on table 23's, here's the destination of the second ID. So however many IDs we have in the realm class family type, or in the actual type table, because like I said in the last video, this is where we're going to start. We're going to start at that type and then move. If a type is created, we know the whole tree is created, and then we're going to shove it in that flat table for the taxonomy tree table. What we know is that all of the information is there. So as I'm designing something like this, because I have done something similar already, not on this system, I want to document the entire process and always learn from your mistakes, try to expand on this even more. What if you want this to go somewhere else? For instance, what if I want table 23 type 2? Dang it. Shifting between Mac and Windows is a pain to get used to sometimes. Some other table. Some other column. So I want this one particular type to go somewhere else. And this might actually be one of our flattened tables. It could be one of these if we want it to. And if we want to look at it, again, abstract it out further, this could be AdventureWorks to an actual split. Like this is where we want to move that data. Now, when we're, in reality, when we're importing that data from an external data source, what we want is a mapping structure that we do have, that I have been using for Reddit and for other bots that I've created to crawl the internet, because there's some transformation that happens. It's not a simple A to B, because it's A never looks like what I have. But if A did look like what I have, then I would take this approach, because you're already really comfortable that the other individual is thinking about the actual data and not the purpose of whatever company they work for, because their company's not different. Sorry. But if their company stores data, data is data. Data is grouped by subject areas. The business doesn't mean anything. The data is still the same. It's just how you organize it. So this could work in this particular setup if I said, when we dynamically create the code to update or insert or however we want to do this, that we create a cursor and say per table, do this. Since we don't want to use unique or distinct in our actual code, because we want very atomic instructions, data-driven instructions, we would create a relationship that says, hey, this table 23 goes to these two tables using the unique specific data set number or data set ID, however we want to do it. So we create a cursor that says, all right, start with flat, and it'll build a query based on this, and then maybe it says go to flat 2, flat 3, some other table 2, a third or 15th table, like what have you. That kind of works, but if we also look at the system that we've built, we always have that taxonomy ID. So this would be considered the new base table of, let's say, what's something that's close together here? I have decision. So we're creating the decision table, this data point type table. And we still want to create the realm class family type, because this is a pattern-based system. So by having that realm class family type, we can actually have a realm that is specifically meant to handle the transfer between data, DB data, to DB flat, or from internal DB something to DB flat. So we could have a realm there and say, hey, this particular set of code is designed to move data from something in our system to the flat database. And that's why we're going to create that taxonomy up here. So I think this will work based on all of our unique indexes right now. We don't include the sequence. So we don't have to worry about the sequence, because our sequence is nullable. In another system, if you had to worry about the sequence, someone has multiple first names, multiple last names, and you want to, for some reason, not denote that via actual naming so you can piece it out, but you want to denote that by sequence and continually update your sequences as things change, then all you would do is, your sequences would never be nullable. You'd always have to make them at least with the default of 1 and extend that unique index, and you would just have another column. So you would have your source table, your source data point, your source primary key, and your sequence. So then you become more of this 3-piece with like a 2-column type pivot, where we're going to pivot on the column and the sequence to get the other information. So conceptually, it still works no matter what route that you're taking in the system. But for my system pretty basic. I don't have to worry about a lot of the stuff that larger companies with a ton of data have to worry about. So that helps me develop a little faster, but still explain that concept. So what we're going to do is create this. What should I name it? Transformation mover. It's the hardest part of my job is trying to name stuff. Say assignment. No, I can't use assignment. But maybe. Cram. Source to definition. Map. Data point map. I could use data point mapping. We do have a mapping, which is meant for quality. So data point mapping. Does that make sense? Source to destination. And I'm mapping a source to a destination, and I'm classifying that mapping. But specifically a data point mapping, because this is going to be for moving data and not cleaning data. All right. That works. So what I can do is I think I have some code. Yeah, okay. New data sets, then build the data sets. But there's something better? Creating the actual tables. Yep, that'll work. So that'll be the start. Dee-dum. This database. So what I have, 30s, 35, 38. So 35, 38, 36, 37, 5, 6, 7, 8. Bam, 7. So we're going to go from version to flat. Bam, there we go. When it's 37, we want it to be 49. Eventually, I'm going to create, basically transfer this kind of abstract knowledge to React, so I could build modules. So I don't have to do crazy code like this and actually have a interface, but so much more work to do here. 38, this is 50. 35 is 47. So this is kind of how I create my tables. So what I want in the flat database is a data point mapping. So I have my archive and then my mapping, or else like I have all the data that I need. So what we got. Ah, yes, that makes sense, doesn't it? Always forget a step. This is why we need tools. This is why we always need tools. And you should always tell your boss that we need tools. I have to define a subject. That's the problem. So I have this new subject. Where does it exist? It's going to exist in flat main, which is 49. New subject that exists in database 49. This new subject is data point mapping. Data point mapping. Let's see. Do I have an if exist here? Nope. Let's see. If I got. Okay. So my data sets got created, but not actually created. So there we go. Versioning procedures, populating the data points, building the definitions, the indexes. I actually need to build the table first, since I know this piece created, but this piece failed, as I missed a step. Happens. I want to make sure that I build the tables themselves, because I'm going to have to modify the table and then run this information on it, or create the indexes and see how that works, because this is a brand new table shape. We want to do data point mapping, and it's a table. Sweet. Cross fingers. Okay, there we go. Give me my history tables. Mapping class, whole works. Excellent. So you actually got to put that in there too. Oh. That will give us our destination. So let us just do this real quick. We say it was going to be in 49 as main. Actually, this will be pretty easy. Now that I can do it the right way. Excellent. If you didn't know, this is the table that builds my tables. So it also exists on flat. It's called a taxonomy tree. It's only going to build the tree itself. Also a new shape, because flat is in a world of its own. Let's see if this works. No changes were made, but we should be able to find it in history. Yep, there we go. Okay, so now we got all of our stuff for our destination in the move from something to destination, because now we have said that in our dataset table, our table of tables, I now have an ID for the taxonomy tree. So now it has a destination. I'll be running the basically this particular procedure. This generates the data points that are within the tables and assigns other things to them, creates the views, creates the procedures themselves. These procedures are going to be pretty massive. So we just have to think about how we're going to approach this, especially since these procedures are what hold the archive and history. Every time we move data into flat and we move it to archive or history, do we want to track those changes? So the default answer is yes, yes we do. Even though right now it might be like, I just don't want to do it at this time. So before we actually tell the system to find out what columns are here, we're going to create this table. So it has the type ID, the tenant, the name, description, abbreviation, header, key name, sequence, like all this other additional stuff is here. The question is, do we want it? Do we want the name and the key name? Do we want to name each specific mapping point? And sometimes that's a good thing to say the source and the destination, especially if you're programmatically filling this, to say, hey, this is TBL text type dot abbreviation in the name itself to flat 01 abbreviation 6. So giving it a name does kind of help you when you use it versus trying to attach the data point table twice and the data set table twice and then the type and trying to figure out like what's actually going on. Name is supposed to be almost an at a glance, or at least the description at a glance. Oh, I know exactly what's happening here. So I think in this case I'm going to keep the name there. But what we're going to have is int primary key. Let's see. What's the order? Data set, data point, primary key. So sysref data set ID source. No nulls. Sysref data point ID source. No nulls. Ooh. Int primary key source. Actually, this will be a primary key implied. No nulls. patterns, patterns, patterns. Do I do parent implied or do I do implied parent? That is the question. Parent implied. And then we'll repeat this again. Damn it, I did the same thing. Data set, ID, destination, UDT, foreign key. Sysref, data point, ID, destination. So looking at the source table with the source data point and the source record ID, where does it go? Here's the destination information, source information, destination information, naming it, no nulls allowed. Should we be able to clean this? Will we ever redirect? Who knows, it's a possibility. So we just make sure that our defaults are set and all of that good stuff. I think this is good, so I saved it. We'll go back to the flat database. And cross our fingers and hope this stuff works because they're new shapes. Basically, more than a year ago, I created some procedures that would generate these tables, and I've only been dealing with the same shapes. But now we're basically adding new shapes, trying to see if these tools still work. We don't really know. So I'm doing now is kind of like, what do I want to do to these mapping and taxonomy trees? Let me see if the foreign keys were created on this. Oh. Nope. I do want those. I want my system to figure out what columns are here and then generate them. B, I want to make sure my system puts the appropriate default types. I want to make sure that the foreign keys are there. And what will happen here is that it'll, not this one, but this one. What's going to happen is it's going to see the dataset ID and look for this table, find out it's in a different database and say, okay, I cannot actually install a foreign key here. Well, at least that's what I'm hoping it does, because I believe that's the same thing with date. So I want it to create our base views, and I want it to create the definitions of the views, so we get the insert, update, and deletes for all of this stuff. I actually need to do it twice, or do it to two different data subjects. So I'm going to say or taxonomy tree. So let's just see all the views and defaults and cursors and indexes and stuff that we're creating. Archive, history, snapshot. I got trees in here. I got my class. Okay, excellent. So, cross fingers. Says successful. Here's the type ID. Let's just refresh. Oh, we got a key there now. We got more keys now. Default constraints, excellent. And then views. Yep, got all our views created. Do they work? Yep. And then what about history? Is history able to do that? Yep. Okay. It's kind of why you also design your system on patterns, because I mean, it's not very many, but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 30 views right here were created. I mean, that's how many default constraints were created on just this particular table. 30 views here, 30 in snapshot, 30 in history, 30 in archive. Right? Yeah. And yeah, including foreign key constraints and all that stuff. All with a simple run. Like I said, all of these procedures were created in my master data management series, and I'll have a link in the description. I'll go back and add these links. But what that does mean is at least our taxonomy tree destination table now has IDs, and we already know all of our other ones have IDs. So now we can think of actually filling this, and I'll save this, and I will save this. We can think of how we want to move the data from a type table into wherever we want, really. So where to begin? We want to operate on views because we don't want to operate on the tables themselves. We want to use interface main. So actually that means there's something else I have to run because, just created brand new items that don't have synonyms yet. Let's make sure we get all our synonyms there. Sweet. And just reload, refresh. Nice. There we go. Okay, so now we can access them from the database where we're supposed to place all of our actual code. All of our procedures are here. And let's create something that will fill it. So the idea is will you give me a tab out? Yeah. We have this flat item, this repeated copy pattern where it's the same 3, 6, 8 columns for each table, realm, class, family, type. We're going to say that the type table has the group ID tenant in it, and this is determined by the default constraint of the table we created. This is the primary key, so we'll ignore it. So basically, we have groups of data to think about. Bam. Nope. There you go. So these are our defaults for the table itself. These will get handled. Actually, I should bring this up. I'll cut this and bring it down. I'll explain here in a moment. Because I've decided, instead of doing every time my realm is created, move it to this area. I mean, you're never going to see the realm in a reporting structure if there's no type, because when you started these base tables, these base items, they all have to have types. And if a realm doesn't have a class or family or a type, then you'll never see it. So there's no reason to move everything, to move a realm when it's created, a class or a family when it's created, only really for this tree is when the type is created. So the type is the main focus. We're going to pull the tenant who owns this type from the type table. And this data is basically just a repeat. And then we'll have this, the active and trusted flag for the tree itself. We're going to pair with the type to say, hey, is this type active anymore or trusted anymore? Just to kind of let us know what is happening. We could skip that and just have the data itself and turn on and off the table record. Is really, how do you think of it? Do you think of it as the active trusted flag on the table record, or the active and trusted flags on the type record? How do I think about that? I think everywhere in our system, this is based on the record itself and has nothing to do with the internal data. So I'm going to ignore the active and trusted flags, because even if a type was disabled, you still might want to see it in a report. So there's no need to modify or bring that forward, because it's a snapshot of a time that could have been before or after right now. Yeah, after right now. That works. So instead of trying to create this crazy process with multiple joins and dynamic SQL, that's really our data set builder. So we could build a data set builder to attach all this information together and call that data set builder against the data point mapping table to load that data. Or we can work smarter and not harder, since this is a very custom thing, in combining all of these taxonomies together versus this more flat table, which is one specific area that keeps growing horizontally. We can just create a new view. So actually, I might have there we go. Let's create a new procedure. It's not a one-time thing. I'm thinking, so here's all the data we need to create a view. I think we could do it that way. It's a little less data driven than I want, but it serves a very specific purpose. So we want the realm ID. The realm key name. Specific data set number. The name. sequence, the display order. Wait, what? Oh, I see. I see. Because it begins with flag. Get. What is it called? Boom. Why, Microsoft? Fuck. Bad words. Oh well. Pain in my ass. Okay, guess we try this one more time without dragging and dropping, and I will update at a later point in time to prevent that. I want a realm to figure out what that. Just realm cleaning flag, realm cleaning flag. And displayed order got messed up. Realm ID cleanse 2. Alright. Specific ID, key name, the realm ID, the specific ID, the cleanse 2, all that stuff. So that's what we want. For everything. So what I'm going to do is I'm going to create a new set of views. That will help us move this data over. I'll create them all at the same time based on the subject because it'll all be here. So we're going to want all this information, and when we create the view and when we tell our system to look at the view, what is this specific view, it'll be in our dataset table and our data point table. So we'll say this is a create view. Actually, let's keep this part. This view is named, it is a view, it's a functional view. And what the subject name is, so this will be a tree, subject name will come in and it'll be a data set. So fun ref data set tree view. Dataset realm key name, dataset realm ID. That looks good. Oh, since I'm using cross applies here, I need to actually pull my information in. What do we start off? We start off here, so these are fine, but then we will have to get more information. So I want to keep the class ID, family, class, realm. These aren't going to matter. The additional filters, because we're not passing parameters in. Oh, you see that full and okay. So that's for the function. This is for the execute statement. We're not running a function, running a simple view. Drop. Yeah. In case we change anything, we want to make sure that we drop and recreate the view so we could run our other items. We're going to create this on interface because all of these are synonyms. Oh, we have S. Excellent. Excellent. And that will create our view. Let's see. Function execute should be view execute. Just trying to clean up code so it makes more sense. If it doesn't exist, add it. But that's going to add it to the process table. In our case, we want to add it as an actual view. So I just have to look at another procedure I created. This, I've already created this code to be consistent. Why am I going to create it differently? Base. Let's do base. Because I want to make sure after I create the view, this is looking. Nope, that's creating the view itself. And then add. If the view does not exist, we're going to add the view. Sweet. Add the view if it doesn't exist. It'll be subject name. vfun ref data set tree subject name. Okay. Views. we want a new view type. Let's actually see what we have right now. Select star from DBO, table value function, data set. Oh, get data set. No filtering out, please. Actually, we might want to filter down views. Common unsigned. Base delete insert. Okay. So we want to add a new class, family and type of views, because this is not really a common view, it is a functional view. So we're going to say we want a functional view, and this will be the tree function. Excellent. We said we want a new class under realm 2. It's a functional class, new ID 6. New ID 6 unassigned. Oh, new ID 11. This is a tree view. Let's close all this down. Now, actually, Control Z, Shift Z, damn it. Now we should see it. View functional unassigned tree. View functional unassigned tree. Excellent. So it's going to create and give it a new value. Is there anything else that we need? That's it. Just figure out naming conventions. Object, data set, view, tree, create. What else was there? Actually, it's going to be this. And the key name is going to be this also. Length -6. So that's the dataset name. If the dataset name was tbl ref, actually the tree name So okay. Insert view is just called subject class, so it's this. So basically we just need to call it data set or whatever the subject name is, taxonomy, whatever. I know I'm gonna get a couple failures on this. Hopefully just date, geography, and taxonomy tree. That's what I'm hoping. Only ones fail. I think that's good. Sweet. Let's see. Hmm. Way to go. Date, decision, other display tree. Okay, so two of them I'll have to take a look at. Invalid object. Oh, I see. I didn't run my views on those. That is fine though. Do I at least have my new trees? I do have my new trees. Do my new trees work? Oh, yes, they do. Okay. Okay. My display and my other aren't fully functional yet. Display is for parameter-driven content. I'll definitely be doing a video on that, so I can change the content of something that is sent out based on, I don't know, time of day, the gender, or whatever value we have in the system can control what content you see from a data-driven standpoint, so you're not trying to manage content inside of the web layer, or creating some really bizarre looking things. Especially language translation would be another parameter inside this display data stuff. Another I don't have functional right now is just getting prepped for the import. Right now I'm trying to focus on moving data, because if I can move data, then I can import data, and then we'll figure out about how to bring it back. So let's see if I can run the populate. No, let's create. I want this one. I want data set names that are like tree. From the view area. Let's see what that looks like. Awesome. Now I don't need any of this stuff. I just want to populate my data points. Will you work? Oh, yes, you will. No synonyms required. Done with this. Done with that. Sweet. So let's see. Let's do a select data set name, data point name, data set ID, data, damn it, data point ID. Type ID from table value function, get data set tree one view, functional unassigned tree, functional. All right. So now, looking back, long journey, at source destination IDs of the data set and the data point type, or the data point to the destination data set and data point, I can see that starting to come together. If I just reorganize this a little bit. My source and destination for everything. Oh, my taxonomy tree. So it still created some of these views, which is good. At least I have the upper there, but when it was actually trying to create the view, this will get resolved because I do want these in my taxonomy tree. This I can remove, actually not remove, reclassify. And no, I was right, remove. This does not exist, so I could deactivate it, remove it, whatever I want to do. The rest of these, though, are going to serve as my source and destination plus the IDs themselves. So let's see. To fill that, and then my destination data. Oh, that's history. So we want to go to tree to insert. Oh, of course. Oh, there we go. So now I really have my source to destination lined up. If you can kind of follow what's happening, is I will look at a specific tree, so the subject tree. Now I have realm, key name, class, all this stuff with their specific, with the data set and data point IDs, and I will be able to link these to these. So I will just have to create a process that's basically an if not exist insert, else update, where these are filled based on each table in here. Select the destination and with a source. So for each source primary key, it'll create a statement in this particular section instead of pivoting it to the flat table. So I'll have two ways of moving data. One is non-pivot, and the other one is a pivot. But they're really built the same way. So I only have two types of assignments right now. Let's call them classes, because in the realm I want to dictate that this data point mapping is meant for moving internal my model type tables to my flat database. And the class of that, there'll be two types of classes. One of them is to a more vertical structure, because this new ID will help us expand, and this taxonomy tree will help us get more information from our very flat items. And then those very flat items, which pay attention to the primary key itself as where to go in that long horizontal list. So I really only have two classes right now of moving data. One of them is where the key determines length, and the other one is where the key determines the actual key. So how would I do that? It would really be the ID plus the data set. But it'll be the ID plus the specific data set number, which means if I can declare, if we go down the data point mapping, we'll have a family of a function and a family of like just a column. So if it's a function family, I can expect there to be a relationship to a particular process on that specific ID. So if I define this column twice, where one of them is a function under the function data point assignment, I can not only get my specific data set number, actually that would be defining the match, because this would be my match. So let me draw this out. This helps me think about coding in this type of environment. The reusable, dynamic, the more abstract type of SQL is not really making code to get the job done. It's thinking it from, I'm going to think of a way to move data, and I'm going to break it. And if I can break it, it's probably not a good way to move data. So I'll have a realm of, let's call this db any to db flat. I have a particular class of basically pivot versus non-pivot. A family and a type. So on my moving, we'll look at it another way. Select X, where X, if exists, select X from X, where so let's do destination. Select any destination ID from the destination table where a destination column equals something and a destination value equals something. Just in case we have two, we want to program for more than one. If it exists, we'll be updating destination equals source. Where, comma, destination equals source. Else begin, insert into destination. Values source. So we have multiple types of mappings. We have a select mapping, and let's do it right here. We're gonna fill these both out just in case. Actually, yeah, that is what happens. Function, data point, select, where, joins. say that kind of goes away because if my where clause because my where clause in here will be the type IDs, but my where clause in the more flat table will be my source column and my, let's see, my where clause up here, this will be the person, but this is the actual record for that person. So I'll have to come down, have a function to figure out based on my current table, what's my person's column. This is my person's column, and then that will generate itself. So I just have unknown classes for right now, which is totally fine. Select function, data point, select encrypted. So I can decrypt something or encrypt something based on where it's coming from. Excellent. I think that works. Let's call this 2db flat. Standard data point. Data point sent to function. Data point is encrypted. Looks good. Oh, 3 o'clock. All right. Tons of progress. So basically what we did is we set up the very beginning of a module to start moving any data point to our flat database right now, but theoretically any data point, record, whatever, to any data point, record, destination. And kind of started equipping it with ready to, this is the selects, these are the wheres, these are the joins, here are the function versions where we need to send this value to a function or a data point, or is it encrypted, etc. So we can start filling in that data, and I'm going to save this. point mapping whiteboard, basically. I'm going to save this data because this is going to help me create the actual code using the data that we'll be inserting into basically these tables, which will help us bring data from the trees into this taxonomy. Once I get further into the code, like I said, these live videos, I just want to kind of show how I'm thinking, how I'm creating, and then when it's all nice and done, I will just create a video explaining the code itself and attach it to its appropriate series. So it makes a lot more, or it would make a lot more sense to see it instead of traversing hours and hours of thought. But it's really the thought that helps you become a better data anything. So thanks all for those who see this later and those who were here during it. I will see you next time. Try to make this a regular Saturday or Sunday thing. So have fun.